Okay, I've rewritten my question. Are there multiples of w and u that add up to 3v? Now let's just see what 3v means. Okay, I've got the vector v. Let's say that this is a representation of the vector v. So 3v would be v plus v plus v. That means we would put v head to tail with itself 3 times. So now here's the vector. V. Now, I want to add multiples of u and w so that when that sum is formed, some multiple of u and some multiple of w, it gives me the same thing that I get for 3v. So I'm going to put my 3v over here, and I hope it's long enough. It's probably a little short based on the scale of what I have over here. That's actually probably only about 2v, but you'll get the idea. Okay. So this means starting from the initial point, I'll take some multiple of u and add that to some multiple of w to get 3v. I'm going to start with a multiple of u. Okay, and any multiple of u. I mean, here's my vector u. Okay, any multiple of u is going to have the same direction as u. So if I start from the initial point and go along the direction of u, I'm going to go along this line. And of course I could have negative multiples, so I could go in the negative direction. I'm not going to need to do that. I'm trying to get from here to here. Okay, well, if I come out to the right point on this line, then, okay, wherever I am on this line, my direction to the head of the 3v vector, well, as I move along the line, that direction keeps changing, and eventually that direction is going to match the direction of w. So there's some point on this line where my direction from the point down to 3v is the same as that of the vector w. So what I can do is I can do this. To find that point, I can draw my vector w, and then I can draw the line that goes through this terminal point in the direction of w, either the negative direction or the positive. It just happens that that line intersected this one at the point where I stopped it, but naturally these lines would be considered to go on forever. Okay, so now a vector from here to here would be a multiple of u. Any vector along this line would be a multiple of w. So that a vector from here to here added to a vector from here to here would be a multiple of u plus a multiple of w and would equal 3v. So let's sketch that. So let's see, this vector here is some multiple of u. And this vector from here to here, if I've drawn the lines correctly, is a multiple of w. So whatever multiple this is of u added to whatever multiple this is of w is going to give me 3v. Now let's just estimate. Let's see, if this is u, we need what? 1, 2, 3 of those, and just a little more. Let's say that's, oh, maybe about 3.2 u, and this is maybe about, what? There's the length of w. Let's do that. About 1, 2, less than 3. I'd say about 2.7 w. So v equals 3.2 times the u vector plus 2.7 And it's actually minus 2.7, isn't it? Minus 2.7 times the W vector. Because it's going, now I don't know why I said minus. We have to go in the negative direction from here to here, but that's plus. From here to here is plus. Okay, that is the direction of W. Okay, sorry. Okay, so 3.2U plus 2.7W. Now that's all done by estimates, and it's all drawn, and I was at a weird angle with the board, so if you're looking at this, and this vector doesn't look like it's all that parallel to this one, there's a reason for it. But this picture represents a schematic, or is a schematic representing the question of what multiple of U added to what multiple of W gives us the vector 3V.